Okay, in this video, we're going to talk about exponential versus linear growth, but let's first start with linear growth. Linear growth, as you can see, has the word line in it. Now, we know what a line looks like on a graph, but what makes a line, well, a line? See, a line has a fixed slope, but that raises another question. What is slope? Slope is often represented by m, and using this graph, we can see what slope really is. See, we're to take 2 points on this line with their different x values. You have x1 and x2, and their different y values, y1 and y2. So at this point is x1, comma y1, and this point is x2, comma y2. Now, when we look at slope, we see what is the difference in these y values, and we divide that by the difference in these x values. And so we would write change in y over change in x. But that's a little hard to remember. And so what is an easy way to think of slope? An easy way to think of slope is that slope is rise over 1. You look at how much your graph rises over these 2 points, that's this blue line, over how much it runs, right? The horizontal distance and the vertical distance. So what is this vertical distance? How much the graph rises over how much it runs, or this horizontal distance. And so linear growth has it that this slope is always the same, no matter what x's you have here, x1, no matter what the x1 is, no matter what the x2 is, this ratio will always be the same. The rise over the run will be some constant value. And so the slope is constant. And so for a function to have linear growth, it must grow at a constant rate. So let's just look at a nice example of this. You can see this plant that I drew, very proud of it. And this plant grows an inch every single day. So after 5 days, it grows to 5 inches. After 100 days, it grows to 100 inches. The rate of growth is constant, right? It's constant, an inch every day, and therefore it is linear. Same thing for a plant that grows 6 inches a month. After 2 months, the plant is 12 inches. After 3 months, the plant is 18 inches. And so again, the plant has linear growth, or also known as constant growth, or you can say that it has constant growth or linear growth. It doesn't really matter. And so that is linear growth, and now we're going to talk about exponential growth. As you may have guessed, exponential growth has it that the function does not grow at a constant rate. Instead of having our nice linear growth where the slope is fixed, exponential growth is a lot more crazy. But let's not judge a book by its cover, and so let's take a closer look at exponential growth. If you were to look at one of these points on this graph, say this point in green right here, and we were to see, well, what is the rate of change, or what is the slope of this green point, we would find a rate of change of about 0, because even though the graph is still running, it's still having that horizontal distance, it's not really rising. And so the slope would be 0 over how much it runs, or it would just be 0. But if we were to take another point along this graph, say about right here, we would have a rate of change of about 0.5, because now it's actually finally rising. Though it's not rising that much, it is still rising. If you were to keep going on this graph to a point of about right here, this green point, which would be the y-intercept, we would have a rate of change of about 1. And if you were to keep going, we would have a rate of change of about 2. And so you can see that the rate of change is obviously changing. The slope is not fixed as it was with linear growth, and so this is not linear growth, this is called exponential growth. And so eventually this graph will become 100, or the rate of change will become 100, and the rate of change will after that go to 1000, and it will just keep on encroaching infinity. Now you may be wondering why I had 7 random gray letters throughout my video. That's because if you were to combine all those gray letters with the letters LE, you would form a 9-letter word. And if you think that you have that 9-letter word, then I recommend that you go on the Academic Boss YouTube comments page and comment not only the word, but also your name, so that in my next video, I will put the person of the video, and then I will say your name. And so, if you think that you completed the challenge, then I say that you go ahead and do that. But for now, because no one has completed the challenge, I will just have the person in the video be my dog, Prince.